Hi guys, my name is Muhammad Hassan Hamadi from grade 12 advanced from Falahia School, supervised by Mr. Ahmad Ouda. Today's lesson will be about concavity. There will be an introduction, a definition, a theorem, and last, a question. Introduction. A concave function is the negative of a convex function. A concave function is also synonymously called concave downwards, concave down, convex upwards, convex cap, or upper convex. And now let's come to the definition of concepts. Definition. Suppose that f is continuous on an interval a, b, and that the graph changes concavity at point c belongs to a, b. The graph is concave down on one side of c and concave up on the other. Then the point c, f of c, is called an inflection point of f. As shown in the figure, C, f of c, which is the inflection point, there is on the left of it a concave down because the f double prime is less than 0, and on the right there is a concave up because f double prime is larger than 0, as shown in the number line. At the left there is a negative and on the right there is a positive. Second, the theorem. Suppose that f double prime exists on an interval I. If f double prime of x larger than 0 on I, then the graph of f is concave up on I. Second, if f double prime of x less than 0 on I, then the graph of f is concave down on I. Now let's come to the question. F double prime of x equal x squared minus 4x minus 5. F of x will be concave downward on, so we have to find the intervals where the function f of x will be concave downward. The first step is to find the second derivative since we have the first derivative. So we have to use the power rule. We multiply by 2 and subtract 1, and multiply by 4 and subtract by 1. So we'll get f double prime of x equal 2x minus 4. And the second step is to solve for x to find the inflection point. So we have to do now is to make f double prime of x equal 0. So 2x minus 4 equals 0. So we'll take 4 to the other side and we will get 2x equal 4. And this, after that we should divide by 2, so we'll get x equal 4 over 2, or x equal 2. The third step, to draw a line number to determine the sign before and after the inflection point, so you can determine the intervals on which f of x concave upward and downward. So we have to make a number line and put 2 in the middle, and this number line will be for f double prime of x. So we have to substitute an f double prime of x 0, which is from left 2, and from right 2 we will choose any number like 5. So we'll get, when we substitute 0 we'll get minus, and when we substitute 5 we'll get positive. And the second thing is to draw a number line for f of x. So if there is a minus on the left, that means there is a concave downward on the left, and when there is a positive on the right, that means there is a concave upward on the right. So now the last step is to write the intervals. So the intervals is upward from 2 to infinity, as shown in the number line. From 2 to infinity there is concave upward, and from minus infinity to 2 there is a concave downward. That's it. Thank you for listening and wish you a great day.